Before we talk about inverse trigonometric functions, we want to talk about inverse functions in general. What does it mean for a function to have an inverse? Now, we all know what it means for a graph to be a function. So let's look at this x square graph. And it is a function because it passes the vertical line test. And it has the domain negative infinity to infinity, and range, it has only positive, actually non-negative y values. So 0 is included, but no negative number is included. So this is a function, but is it invertible? Well, invertible functions or functions that have inverse have to meet one other condition, and that is, in addition to the vertical line test, they should pass the horizontal line test. And you can see that this function does not pass the horizontal line test. There are so many horizontal lines that cut the graph in more than one point. So in the regular square function where the domain is negative infinity to infinity, this does not have an inverse. However, we can turn this function into one that has inverse. If you restrict the domain, if you take only a small portion of the graph, for example, from here to here, then look, this piece of the graph passes both horizontal and vertical line tests. So if you cut the domain, then it may be possible to have an inverse. And that's what we want to do. And in fact, we want to cut the domain in such a way that all the range values are included. So let's look at this graph. Now, I want to include all the y values, so starting at 0. So if I just pick the origin and to the right, then this function is f of x square, but with domain x greater than or equal to 0. So its domain is only from 0 to infinity, and its range is also 0 to infinity. Now this function has an inverse, and that's what we call the square root function. Square root function is the inverse of this square function with restricted domain, where we restricted the domain to be just the non-negative numbers. So when you look at the graph of trig functions we have before, so the graph of trig functions, so let's look at the graph of sine. Sine looks like this. Remember, it's a sinusoidal curve and it passes through the origin. Cosine starts at the top, and that has the same shape as sine, but it does not start at the origin, it starts at 0, 1. And so you can see that sine and cosine, they don't pass the horizontal line test. And similarly, tan graph was drawn. Again, this does not pass the horizontal line test. So how do we restrict the domain? And just like with x square, we want to restrict in such a way that you're going to have all the values in the range. So the range, so let me actually go ahead and write the domain and range for sine function. So here the domain is negative infinity to infinity. You can plug anything. And the range is, it goes from negative 1 to positive 1, including the boundary points. And same thing for cosine. I can write the domain as negative infinity to infinity, and the range is negative 1 to positive 1, closed interval. So if I want to include all the range values, then this is what I'm going to do. I want to have negative 1 to positive 1, but I only want to have one branch or one section. So look at this part of the graph. So sine function restricted to just this domain, negative pi over 2 to positive pi over 2, will be invertible, and it would have the same range from negative 1 to 1. Now what would I do for cosine? Again, I want to include that section that's near 0. So here it made sense to go to the right of 0 and to the left of 0. Now if I want to think about restricting cosine, then I don't want to go to the left and right of 0, because then notice that it's not going to pass the horizontal line test. So maybe I want to start here and then go to the right and then stop here. This way the graph passes the horizontal line test. So thinking about these two functions, for the inverse function, now what happens is the domain and range, they switch. So what's the restricted domain for sine function, this newly defined sine function? It was negative pi over 2 to positive pi over 2, and the range was negative 1 to 1. So let's write down the domain and range for inverse function. So if I say f of x equals sine inverse x, let's go ahead and write the domain and range. So domain and range for inverse functions switch. So whatever the range here, I'm going to have the domain, which means the domain would be from negative 1 to positive 1, closed interval. And the range would be the domain of the restricted function. So the restricted function went only from negative pi over 2 to positive pi over 2, and it included the boundaries. So negative pi over 2 to positive pi over 2. So that is sine inverse. Let's look at cosine inverse. F of x equals cosine inverse of x. Domain and range. So if I want the domain of cosine inverse, I got to look at the range of cosine function. So that is again negative 1 to positive 1, just like domain of sine inverse. Now the range of cosine inverse would be the domain of the restricted cosine function. Here cosine function varied from 0 to pi, and again it's closed interval. So that becomes the range for cosine inverse. So 0 to pi. It's closed interval. And let's also think about tan function or tan inverse x, and write its domain and range. Now tan function had a graph that looked like this. If I want to consider one section that would include all the range values, and that is near 0, and it passes the horizontal line test, I would be interested in this section. So this is 0, and I would be interested in this particular section. So the restricted domain, or actually let's focus on the range first. Range of this tan function is going to be everything, negative infinity to infinity. That forms the domain for tan inverse. So let's write down here, domain of tan inverse is negative infinity to infinity. Now, what is the range of tan inverse? Is the restricted domain. The restricted domain went from negative pi over 2 to positive pi over 2 because that's where we are restricting our domain to be. And notice the endpoints are not included this time. So the range for this is the restricted domain, which is from negative pi over 2 to positive pi over 2. So that those are the domain and ranges for inverse trig functions in one page. Now notice that inverse trig functions, they take a number and they produce an angle. You remember sine, cos, tan, they took an angle and gave a number. We said sine pi over 2 equals 1. That pi over 2 was the angle. So it took an angle and gave us number. Inverse trig functions, they take a number and they result in an angle. So sine inverse, cos inverse, they take numbers between negative 1 and positive 1, including the boundaries, and they produce these angles. Sine produces angle in the fourth and the first quadrant. It goes from negative pi over 2 to positive pi over 2. Whereas cosine inverse will produce an angle in the first and the second quadrant. It goes from 0 to pi. Now tan inverse can take any number, any real number. And it produces an angle just like sine inverse. It produces an angle in the fourth and the first quadrant because negative pi over 2 is obtained when you go in the clockwise direction. So that takes you into the fourth quadrant. So range of tan inverse lies either in the fourth or the first quadrant, just like sine inverse. But sine inverse has the boundary points and tan inverse does not.